where the carbon which we are talking about has to be attached with how much number of carbon. Hello everyone, welcome to PLUTUS STEM. So we were discussing regarding the organic compound in this series. We are back with this second lecture of this organic compound, how we can classify this. In the previous lecture, we have classified these organic compound on the basis of their structure. We have classified like this. Just a quick recap of that: cyclic and open chain compound. And these open chain compound were again classified as branched, chain and straight chain, or you can see unbranched. And these cyclic compound we have subdivided into two classes: aromatic, homocyclic, and you can say heterocyclic. Either this way we can classify like homocyclic and heterocyclic, and another way is to classify these cyclic compound is like this. I will show you over here. Like cyclic can be classified as aromatic and non-aromatic. In this non-aromatic, we can have, in this non-aromatic we will have heterocyclic and homocyclic. Over here, if you come over here, in this aromatic we have three: benzoate, non-benzoate, and the third one is heterocyclic. This is the thing which we have discussed in the previous lecture. So continuing from there, now again, this is also the way you can classify the homocyclic and heterocyclic, and these heterocyclic can be of two types: aromatic and non-aromatic, and these homocyclic can be benzoate, they can be again classified into two, like aromatic and non-aromatic, and these aromatic can be benzoate and non-benzoate. So this is the way, just to classify, to study these organic compounds in a better way. This is the way, this classification we have studied in the previous lecture. If you want a detailed knowledge about it, you can go into the, we will provide the link of this previous lecture also. Yeah, so this is the way how we can classify this organic compound. In that previous lecture, I have explained the structures of also of these benzoate, non-benzoate, heterocyclic. So all these examples have been studied with the structures. Yeah. So today we are going to discuss another type of classification of these organic compound on the basis of attachment of carbon. So this attachment of carbon, if you see over here, how we are going to classify this type of compound on the basis of the attachment of carbon. Which carbon we are having over here, like primary carbon, secondary carbon, tertiary carbon and quaternary carbon. So this can be of four type. primary, secondary, tertiary, and quaternary. So four type of our carbon are there, where the carbon which we are talking about has to be attached with how much number of carbon. So if we are saying yes, so regarding this primary carbon, if this is the group, this is a functional group, we are saying talking about alcohol, let's say. So in this alcohol we will see that this alcohol is attached to a primary carbon. So this alcohol will be termed as primary alcohol, and this is a secondary carbon. This is a secondary carbon. So what is the difference between primary carbon and secondary carbon? The carbon of which we are talking about has to be attached with only one carbon. If this is our carbon, we are talking about carbon 1. Let's say this is 1, this is 2, and this is 3. So this CH3 is attached to only one carbon, that is C2 over here. So this is a primary carbon. The same case with the carbon number 3 also. This is also attached with only one carbon, that is carbon number 2. So it is also a primary carbon. But when we talk about the carbon 2, that is being attached with two different carbon. So this carbon is termed as secondary carbon over here. So we can have some more example of this secondary carbon. I am omitting this, you can say hydrogen over here. You can place the hydrogen like this: 3 hydrogen, 3 hydrogen, 3 hydrogen, 2 hydrogen, and 1 hydrogen. This is the way how we attach the hydrogen at these different carbons. So yeah, so this carbon, if you see, is a secondary carbon. So sometime in a NEET exam, we can have a simple type of question that how many primary carbon are there in the given compound. So it is quite simple that this is the only carbon which is having the secondary carbon, which means attached to two different carbons. This one and this one, carbon 1 and carbon 2 are again the primary carbon. They are only attached to single carbon atom. So yeah, coming back to this primary and secondary we have discussed. Now we will talk a bit about tertiary and quaternary carbon. Tertiary carbon, the same thing over here. The carbon which we are talking about is attached with how much number of carbon? This carbon, if you are talking about, is attached to how many different carbon? 1, 2, 3. So this carbon is a tertiary carbon, and this alcohol will be termed as tertiary alcohol, or if NH group is there, tertiary amine, like this. In the same way, the group which is attached over here, on the basis of that, we call the name of that whole group also, on the basis of this carbon. So this is for tertiary carbon, and again one more example we can take over here. This is also a, if we want to see over here, this is also a tertiary carbon. This one. Attach 1, attachment 2, attachment 3. 3 attachments are there, which means it is also a tertiary carbon. So now regarding the quaternary carbon, so the attachment of carbon with 4 different carbon, that attachment is being termed as quaternary carbon. So we can see over here which carbon is a 4-degree carbon. So quite obvious, this one is our quaternary carbon. One attachment, 2 attachment, 3 attachment, and 4th attachment. So the important point over here is the attachment should not be like alcohol or aldehyde or something like that. The attachment should be carbon. So this attachment is carbon 1, 2, 3, 4. 4 different carbon should be there. That's why we will call it as tertiary carbon. 3 carbon are there, tertiary carbon. 4 carbon are present, we will call it as a quaternary carbon. 2 carbon are attachment are there, we will call it as a secondary carbon. So this is the way how we can classify our organic compound on the basis of these different primary, secondary, tertiary, and quaternary carbon. So now we will discuss a bit about some common names are also being named like this: iso and neo. Iso. So iso is like something like same. The term iso came from same, isomer. Same and monomers are the same structure are being over there when we call it as isomers. So same name over here. This iso prefix is being used when we are having this type of moiety. Generally, it is being used when the second last carbon. Generally, this iso term is used when second last carbon is having 2 different carbon, CH3 and CH3 at the same. So these 2 are same. Generally, it is being used like this. So this is iso. 1, 2, 3. So this will be termed as methane, ethane, propane, butane, pentane. Isopentyl we can call it as. Clear or not this thing? So if we are having this thing like this, this CSCC and this type of moiety, we can call it as a isobutyl. This is the second last carbon attached to 2 different carbon that are same. This second last. So generally, this is the way how we differentiate between these 2 iso terms, and someone can call it as secondary also. There might be some student, so sir, it is secondary or it is tertiary like this. Why we are calling it as iso? So there is a way when there is a functional group, then generally we use term tertiary, secondary, like that. So when these are not functional group, so we use the term for like hydrocarbon and alkyl halides. So for such type of group, we use the term iso and neo. Generally, we are using this secondary, tertiary, quaternary term for functional groups such as alcohol, aldehyde, etc. So yeah, so the neo term is being used when the second last carbon is being attached with 3 different groups. 1, 2, 3. So this is our neo 3 to 5 neopentyl. Clear or not? This thing. This we will be calling as neopentyl. So generally, if this the second last group is having three different carbon, then we will call it as a neo. We can have a compound if the thing is over here like this. If we are having a group like this, so what are you expecting this name to be called as? This compound will generally call as tertiary. Why tertiary? Because if in this type of group, generally this it is a 3-degree carbon, 1, 2, 3, tertiary. It is being attached to some, most of the time it is most probable it will be attached to some functional group. So that's why we are calling it as tertiary side chain, tertiary butyl. It will be termed as tertiary butyl. And if we are having neopentyl, I have just discussed in the previous slide only. So this is the way how we can you can say classify. So one more thing is being left over here. One more terminology which we use is 1 degree, 2 degree, 3 degree and 4 degree. What does this degree terms mean? So there is nothing special about these terminologies as 1 degree, 2 degree, 3 degree and 4 degree. These are simply primary, secondary, tertiary and quaternary carbon. There is nothing special. 1 degree is termed when we are having primary carbon. 2 degree is being used when we are having secondary carbon. Three degree for tertiary carbon and 4 degree for quaternary carbon. So this is the way how you can classify these organic compound on the basis of the attachment of this carbon. So another way is like on the basis of their hybridization, or you can say unsaturation. So firstly, these you can say any compound. I think most of the aliphatic compound can be again subclassified into like unsaturated and saturated compound. So what does this saturation and unsaturation mean? Firstly, we are going into the detail of that, and then we will proceed further. Saturated compound are those compound that doesn't have any double bond and triple bond inside their whole structure. So if we are having any hexane, pentane, butane, so these compound they are not possessing any, you can say, unsaturated group, like say double bond and triple bond. So these compound are termed as unsaturated compound. So if you are not familiar with this bond line structure, how we are saying it is hexane, pentane and butane, for that also we have provided a separate video on the bond line structure with the name like basic concept of chemistry. In that we have discussed in quite detail regarding all these bond line structure, how these organic compound are represented, which is like dot, what does this dot represent, what this line represent. This all thing has been discussed in the detail. That the link will be provided below, and you can go over there and visit and watch that video regarding this bond line notation of organic compound. Regarding unsaturated, another way is unsaturation, which means the saturation, no double bond, triple bond. Unsaturation means presence of double bond and triple bond. This can also be subdivided into two classes, alkene and alkyne, which means double bonded carbons or moieties, and triple bonded moieties. So this we will get in the detail of this when we will be studying alkane, alkene, and alkyne. We will go into the detail of that in that portion. Today, I will just make you understand that this is butene. 1, 2, 3, 4 carbon. 1, 2, 3, 4 carbon. But 1 ene. This is prop 1 ene. This is 1, 2, 3, 4, 5. Pant 2 ene. So this way these are unsaturated compound, and we can say I have like this 1, 2, 3. Prop 1 ine. One other 1, 2, 3, 4, 5. Pant 1 ine. So this is the way how we name these compound, and that also we are going to study in quite detail in the upcoming videos regarding the nomenclature of organic compound. So the saturated compound, unsaturated compound. Regarding the hybridization, what is hybridization? That you have covered in the inorganic chemistry, that sp3, sp2, sp, and many more hybridization we have studied in the inorganic chemistry, the chapter named chemical bonding. Over here we have studied these concept in quite detail. On the basis of organic chemistry, we are only going to deal with three type of hybridization: sp, sp2, and sp3. So in these three hybridization, if we are going to the depth of these hybridization, what we are going to see over here, that if any molecule or moiety is having a sp hybridized bond like this, like this. So this is sp hybridization. The classification can be based on this. If any molecule is having like this, sp2 hybridization, this is sp2, this is also sp2. These two are sp2, sp2. This is sp, this one is sp2, this one is sp2. So this is the way how we this one is sp. So this is another way how we can classify these organic compound. And regarding sp3, all the other atoms are sp3 only. In this, all the atom are sp3 hybridized. Like this, any atom we can take over here. So this is the way how we can classify these organic compound on the basis of hybridization. So in today's lecture, we have discussed up to now regarding the firstly we have recapped that structural based classification of organic compound. After that, we have discussed like primary, secondary, tertiary, and quaternary hydrocarbon classification of this organic compound. After that, we have discussed iso and neo term, and after that, now we are discussing regarding this hybridization term, how we can classify these organic compound on the basis of their hybridization. Now the next thing which we are going to discuss is functional group classification. on the basis of functional group. So any organic compound which is having different functional group, that can be like alcohol, it can be phenol, it can be ether, it can be aldehyde, it can be carboxylic acid. All these things is going to come in our class 12. So if you see over here, like alcohol, if the compound contains this type of moiety, it can be aldehyde, this type of moiety, it can be ketone, it can be as carboxylic acid, and many more like ether, and ester and hydride, oil chloride. So many more are there. So this is the another basis on which we can classify these organic compound, that this is the another compound. And if you are not familiar with this compound, we are going to discuss these all in quite detail in class 12 chemistry. Yeah. So now regarding the homologous series. So if you see regarding this homologous series, what is a homologous series? So a group or series of organic compound consists of a characteristic functional group that we have discussed just now. What is a functional group? Like alcohol is there, phenol is there. So there is a group of those compound, or you can say there is a series like 1, 2, 3, 4, 5, this. So those compound which contain only like alcohol is coming, the methanol, ethanol, propanol, butanol, like this. So those group they form a homologous series. A group, or we can say series also. A group or series of organic compound, a group or series of organic compound containing a characteristic functional group. And functional group we have discussed just now, like it is having alcohols, or either it is having aldehyde, either it is having ketone, carboxylic acid, ether, and hydride. So such type of series or such type of group are termed as homologous series. So it is not like any series is going to be called as a homologous series. So there are few criterias. There are few criterias are there on the basis of which we can call it as this is a homologous series and this is not an homologous series. So if we want to call any function, any series or any group as a homologous series, it must have same functional group. It must possess a same functional group. The second thing which should be over there is same DBE value, double bond equivalent. DB is double bond equivalent. And the third thing is same, or you can say it's not same, is not better but similar. Same functional group is quite right. Same DB is quite right. Similar chemical properties. Similar chemical properties. And a gradation in physical properties, such as boiling point and melting point, etc. So many other physical properties. There will be a probably grading, which means if you are having methane, it is the properties like this. So at ethane it will increase, at propane, methane, butane, like this. So this is the gradation in physical properties. So it will increase with the increasing in the number of chain. So how these groups and series are like increasing. So we will see one more point is there, that is quite important. Two consecutive member. Two members that are consecutive must possess a difference of CS2. So if a number of series is there, so one compound is having this formula, let's say. So another will have plus CS2, and the next will have plus CS2. So like this way, the series will be continuing, and they are going to have a same general formula also, like CnH2n plus 1, CnH2n plus 2. Same functional group, same DB, similar chemical property, same general formula. So these are like property for any homologous series. So this is the way how we can say that this is a homologous series and this is not a homologous series. So one more thing which we are going to discuss in this class or in the next class is that we will be discussing a bit more regarding the nomenclature of these organic compound, how these, yes, how these organic compound are being named, that we are going to discuss in the next upcoming lecture. So one thing which is being left, if you are not aware with to the DBE. So what is the formula to calculate this DB is carbon plus 1. Number of carbon plus 1. The how, if you want to calculate DB in any compound, so we need to see that the number of carbon present in that molecular formula of that compound, we are going to add 1, then subtract the number of hydrogen, divide by 2. Then we are going to subtract the number of hydrogen, divide by 2, number of halogen, divide by 2, and add the number of nitrogen, divide by 2. This is the way how we can classify, you can say found the DBE value of any organic compound. So this must be quite same. I mentioned over here. So it is quite important to tell you what is DB if you are not familiar. And this thing we are going to discuss in the next upcoming lecture. We will be discussing regarding the nomenclature, isomerism, nomenclature. So these two important topics and some more the small topics which are being remain in this basic organic chemistry, and after that we will proceed for the general organic chemistry. If you have any query regarding anything which we have discussed, like you need some detailed video of that, you can comment that I will provide that also. So in today's lecture I will just give you a quick review of this what we have discussed up to now. In the today's lecture we have discussed how these organic compound can be classified on the basis of their structure formula. This thing is being discussed in quite detail in the previous lecture. So this is the two way how I have classified these. On the basis of attachment of carbon, this four way, primary, secondary, tertiary and quaternary. This thing we have discussed in quite detail. After that we have discussed regarding the iso, and neo, the difference between iso and neocarbon, and regarding the tertiary and secondary we have discussed. Yeah, tertiary and secondary, 2 degree. So secondary also, tertiary and secondary, like saturated and unsaturated compound. Regarding the hybridization, sp, sp2, sp3, classification on the basis of the functional group, we have discussed regarding the homologous series and what are the characteristics of an homologous series that should be present, the criteria over here, and the what is the dB value, how we can calculate this dB. In the next class we are going to discuss these terms like isomerism in quite detail, stereoisomerism, chain isomerism, structural isomerism, optical isomerism, all the things which we are going to discuss in the next upcoming lecture, and regarding the nomenclature and many more. That's all for today. Thank you.